right, now we're on Unit 3, Day 4. So today we're going to name and write formulas for ionic compounds with transition metals. So last time we used group 1 and 2 metals. Now we're going to use the other metals to write ionic compounds. It's going to be really fun. All right, so your transition metals are in the middle. They are groups 3 through 12 or your B groups. They're the ones that we didn't look at their numbers for valence electrons because they're a little bit different, okay? Many transition metals have more than one possible oxidation number, okay? Sometimes we give away 1 electron, sometimes 2, sometimes up to 7. It kind of depends, okay? So these are the ones you need to know, okay? Silver is always 1, zinc is always +2, and cadmium is always +2. This is why we've labeled these on your periodic table. And if you didn't, then you need to go back to day, 3, and rewatch that and follow along, okay? So your transition metals, since these metals can have different oxidation numbers at different times, we need to specify which charge it has, okay? We specify the charge by using our Roman numerals for these elements. Okay, Roman numerals are the ones that they look like the I, so this would be equal to 1. If you have 2 lines, that's equal to 2. 3 lines is 3, and IV is 4, okay? Then V is 5, VI is 6, and so on. All right, so now we're going to write these out. So I is 1, 2 I's is 2, 3 I's is 3. An I before the V is 4, then V is 5, VI is 6, VII is 7, then 8, IX is 9, and X is 10, okay? If you know what the Roman numerals are in Super Bowl, then you have no excuse. You need to know these, okay? So which elements need a Roman numeral? It's faster to say which ones actually don't. So our ones that we label our valence electrons with, those don't need a Roman numeral. Also, nonmetals don't need a Roman numerals, okay? So you need to mark these on your periodic table. So here's some example. You have your name and then your formula. So copper, I, is copper +1. Iron with 2 I's would be Fe as iron +2. All right, now we have Cr +3. Now Cr is chromium. And if it has 3, then that means we need to have 3 total Roman numerals in here, okay? And then 10 is 4, okay? So I before V is 4. So 10's symbol is Sn +4. All right, so let's do an example. Now we have copper 2 fluoride. So for step 1, we need to write the symbols, your cation first, and then your anion. So we're going to write your cation in red, okay? So copper is going to be your cation. So it's your metal, it's positive. So we're going to write Cu first. That's copper, all right? And then we're going to write our anion in blue. That's going to be fluoride. Remember, your anions are negative and nonmetals. So F is going to go over here, okay? We're going to rewrite our symbols, Cu and F. All right, step 2, above each symbol, we need to write the oxidation number or the charges. All right, so for copper, it's given to us, okay? Copper has 2, so +2. And then fluorine is in group 17, so it has a charge of -1. All right, we're going to rewrite this. Copper, Cu +2, F, -1. Then, just like we did with our normal ionic compounds, we're going to switch our charges. So +2 will go over here, +1 will go over there. And that gives us copper, Cu, with a charge of 1. And we have fluorine, oops, that's supposed to be blue. 1 second. Fluorine with a charge of 2. All right, then we reduce and erase, but mine are already erased. So we're just going to reduce, and our example would be CuF2, copper 2 fluorine. All right, let's do some more examples. So now we have 10,2 chloride. All right, we're going to write our cation in red and our anion in blue. All right, so 10 has a symbol of SN. Chlorine has a symbol of Cl. Okay, 10 has its charge given to him. Wow, now I can't talk. So 10 plus 2, and chlorine has a charge of -1. All right, step 3 is to switch. Woo. And we're going to go ahead and write it off to the side, all nice and pretty. We have SN with a charge of 1, but we don't need to put the 1 there. I'm going to write it in anyway. And then we have chloride Cl with a charge of 2. Not charge, just put the 2. Okay? If you wanted to write it even prettier, you would just write SnCl2. Beautiful. 10,2 chloride. All right, next one we have copper 1 oxide. So copper is our cation. We're going to write that first. Cu, and its charge is given to us. Ooh, I don't want to write it up there actually. We're going to write our chart. We're going to write it down here so we can practice. Cu plus 1, and oxide is going to be our anion. Oxide is oxygen, and it has a charge of -2. All right. Step 3, we're going to crisscross our charges. We're going to go ahead and write it nice and pretty up here. We have SN. Sorry, I'm looking at the wrong one. We have Cu, copper, with a charge, or with 2 down here, because we took our 2 and moved it over. And we have oxygen, 1. And now we're going to make it even prettier if that were possible. Copper, Cu, 2, oxygen. All right. Number 3. We have lead 4 sulfide. All right. Lead has a symbol of Pb, and its charge is given to us, +4. And then sulfide is sulfur, which is S. And sulfur is in group 16, so it has a charge of +2. All right. Step 3 is to crisscross these good charges. And we're going to have Pb2 S4. All right, step 4 is to reduce. So we're actually going to divide this by 2, because 2 can go into 4. And we're going to write it all nice and pretty off to the side right here. We're going to have PbS2. All right. So naming a transition metal, if you notice that the formula of a compound has a transition metal, then you must use a Roman numeral in the compound's name, unless it's in your exception block. All right? From now on, you won't need to know which kind of ionic bond you're naming without looking up the metal on the periodic table first. Get used to thinking of it as like a step 0. You always need to reference your periodic table before you start. Okay? That way you can decide if you need a Roman numeral or not. All right, so step 0, find your metal in your periodic table and decide if you need a Roman numeral. Step 1, you name the metal first and use a Roman numeral to indicate the oxidation number. And then step 2, you name the nonmetal and change the ending to IDE. All right, so finding the oxidation number, you'll have to uncrisscross the subscripts back up to the oxidation numbers and check the nonmetal's oxidation number to make sure it's right. All right, if it is, you use the metal's oxidation number in the parentheses as your Roman numeral. And if it's not, you correct the metals by doubling or tripling and then correct the metals the same way. Okay? So let's do some examples. So right here, we had iron 2 chloride. See how we had FeCl2? So we took that charge and put it right back up here above where it went. So Fe plus 2 Cl minus 1 was how it was originally written. All right? That's how we got the 2 for iron 2. All right? So the next one we're going to do is chromium 3 with nitrogen 2. We're going to uncrisscross these numbers. I'm going to write this off to the side. So chromium had a charge of +2, and nitrogen had a charge of +3. So the way we would write this out is chromium 2 nitride. All right. The next one we have is copper oxide. And we notice it doesn't have a charge on it. But if we look at oxygen, we know that oxygen is in group 16. So it did have a charge, okay? So we're going to write copper and oxygen over here, okay? We know that oxygen had a charge of -2. This should have been -3, my bad. -2, okay? So if we had 1s for each of these, that means we need to multiply by 2 on each side, okay? Because that's how we got to oxygen with a -2. So copper should also be +2. Remember, step 4, we would have reduced, so we would have divided by 2. But we need to go backwards and multiply it by 2 to get the correct charge. So the answer for number 3 is, that's not an H, copper 2, that's not a Roman numeral, 2 oxide. All right? Notice that your Roman numeral often corresponds to the subscript of the other atom. Okay? Now let's do some more. So we have manganese oxide. Okay? This is almost the same as the other one. We knew that oxygen had a charge of -2. Okay? So we need to multiply both sides by 2. We know that manganese had a charge of 2, okay, before it was reduced, oxide. All right. Next we have zirconium with sulfur, zirconium sulfide. All right, let's uncrisscross these charges. This was a 1. So we would write zirconium 1 sulfide. All right. Next one, we have silver oxide. Okay. We're going to put that charge back up where it was. And we're going to put this one back here. But notice silver is one of your exception metals. Okay. So we don't need to write the charge for silver. Okay. So all we're going to write is silver oxide, because it will always have a charge of +1. Okay? Now let's do some more. Okay, so we have silver. We have phosphorus. So silver phosphide. Silver is one of your exception metals, so we're not going to write in that one. All right? Next one, we have sodium nitride. All right, that's just a normal ionic bond. Sodium nitride. All right, next one, we have nickel, which is a transition metal. It's in group 10 sulfide. Okay. Sulfur has a charge of +2. Okay, it's in group 16, so it has a charge of -2. Sorry, -2. It's a nonmetal. Which means that we need to multiply both of these ones that are originally down here by 2. So that means nickel had a charge of +2. So this would be nickel 2 sulfide. Right? Next one is beryllium fluoride. Now beryllium is in group 2 and fluoride is in group 17, so that's just a normal ionic bond. Beryllium fluoride. Right? Next one we have is gold chloride. Ooh. Now gold is in a transition metal, and it's also not inside your exception metals, so we need to take that charge of 4 and put it back up where it was over here. Okay, so this is going to be gold 4, which in Roman numerals is IV, chloride. All right. Now the last one we have is potassium sulfide. Potassium is in group 1 and sulfide is in group 16. So we do not need to make an exception for this, and we're just going to write potassium sulfide. All right, here's the answers in case you couldn't read what I was saying. Make sure you go and take your quiz, and good job.